Okay, let's talk a little bit about probability distributions. Here I have a probability distribution, just abbreviate. Okay. And X represents the number of cans of soda consumed in a day. And this is not actual data, I've just made this up for this example. So you can see here that 28% of people drink 0 cans of soda in a day, 42% drink 1 can of soda a day, 16% drink 2 cans of soda a day, so on, and 2% of people drink 5 cans of soda in a day. Okay, so that's what this is telling you. And let's talk about how to find the mean and standard deviation for probability distribution. Before you do that, the first thing you want to do is make sure that this table actually satisfies the characteristics of a probability distribution. Okay? So the first property you want to check is, are each of these between 0 and 1? And you can see each of these probabilities is between 0 and 1. And the second thing is, do all of the probabilities, so this is summation, do all of the probabilities sum to 1? And if you add these numbers together, they do sum to 1. Okay, so this is a valid probability distribution. So let's use our calculator to find the mean and standard deviation for this probability distribution. So first thing you want to do is put this data into our calculator. So I'm going to go over to Stat, okay, Edit, and let me put this data into some empty lists. So I'll just use list 3 and list 4. Okay, so you want to enter the data just as you see it. You want to put the X values in one column and the probabilities in the other. So now I have my data in these lists. Okay, you want to go to Stat, Calc, one variable statistics, and I want to do one variable statistics on L3, comma, L4. Okay, and then if you hit enter, you will get the okay, so you can see here that I have the one variable statistics on this list. And n here equals 1. That's just telling you that all these probabilities sum to 1. Okay? And then the 5-number summary is also there. But let's look at the mean. The mean here is 1.23, and the standard deviation is 1.15 or 1.16. Okay? So look at that 1.23. Okay? Does that look like a valid mean? Well, most of my data is where? It's here, right? It's heavier here. There's not that much data here, only 9%, 3%, and 2%. But most of the data, 28%, 42%, and 16% is here. Okay? And it's saying that the mean is somewhere inside here. Okay? So that does make sense. Okay? Okay, let's talk a little bit about expected value. What is the expected value? Well, the expected value is simply the mean in the long run. So if you were doing an experiment like flipping a coin or rolling die, if you kept on doing it, the expected value would be the mean if you kept on flipping that coin, okay, or kept on rolling that die. Okay? And what the expected value does is it takes into account the chances of each outcome. And we abbreviate the expected value as E of X. Okay? And it's the average outcome That's why we also call it the mean in the long run. It's the average outcome for infinitely many trials. Okay, let's do an example. And the example we're going to look at is roulette. So let's look at what a roulette wheel is if you're not familiar. Okay, here's an example, some examples of roulette wheels like this. Okay, and the way it's played is you bet on a number. Okay, like this roulette wheel, most roulette wheels have 38 slots. Okay, and you bet on one of the slots. So let's say I bet on number 7. Okay, and they throw like a shell or a small ball into the wheel, they spin it, and if it lands on number 7, you win. If it doesn't land on number 7, then you lose. Okay, so let's do an example. You can bet on any number that you would like. Okay, so let's suppose you bet $5 on number 7. Okay, there are total 38 slots on this roulette wheel, and if you win, you get $180. Okay, so let's make a probability distribution for you. Okay, now there's two options: either you win, right, or you lose. If you win, you get $180, but you bet $5 to play the game. So your net is going to be $175. Okay. Now, how often is that going to happen? Well, there's only one way that can happen, is if the wheel lands on number 7 out of total 38. Okay, so there's a 1 in 38 chance that you will win. If you lose, then you lose that $5 that you bet. Okay, so the net is negative $5. And what's the chance of you losing? Well, there's total 37 slots that are not number 7 out of 38. Okay, and let's calculate your expected value. Okay, the formula for expected value is summation x times p of x. Okay, that very simply means that you take each x value, okay, these are our x values, you multiply them by their own probability, and then you add up all those products. So I'm going to take 175 times 1 out of 38 plus a negative 5 times 37 out of 38. And if you plug these numbers into the calculator, then you get negative 0.26. Okay? This means that if you continue to play infinitely, you're going to lose 26 cents in the long run. Okay? This is your probability distribution and your expected value. Let's calculate the casino's expected value. Okay? Now, if you win, what happens to the casino? They have to give you $180, right? So they lose $175. What's the chance of that happening? 1 out of 38. There's only one way you can win, is if you land on number 7. Okay? What happens if you lose? Well, if you lose, then they win, right? How much do they win? They get your $5. And there's 37 ways that can happen, is if you don't land on number 7. Let's calculate the expected value for the casino. Okay, so again, the same formula. You take each x value, multiply it by its probability, okay, and you add up all those. Let's just do it this way. Okay, all I'm doing is multiplying each number by the value, You add those up. If you plug that into the calculator, you will get positive 26 cents. So if you kept on playing, the casino will win 26 cents in the long run. Okay, so this is called the house advantage, meaning if you keep on playing, you're going to end up losing and the casino will end up winning. Okay, and we can do the same thing with lottery and with any other gambling game. Okay, they all work the same way, and coincidentally the house always has the advantage. Okay, casinos are there to make money. They're in business, which means they're making money, and they're making money off the consumers. So I guess the moral of this story is gambling rarely pays. Right? So I guess if you go gambling, you got to be smart about it and know exactly when to stop. Okay, let's calculate the expected value for our original probability distribution. Okay, so the expected value is, again, you take each x and you multiply it by its own probability. So I have 0 times 0.28 plus 1 times 0.42 plus 2 times 0.16 and so on. Okay, and if you plug this into the calculator, and hit enter, you'll get 1.23, which is the exact same thing we got before as the mean. Remember when we did one variable statistics on these lists, we got 1.23 as the mean. Okay, so that's what we get as the expected value here. So you can see that the expected value really is the mean in the long run.